Hi and welcome back. My name is Tom Brennan and this is the second video in a series on how to make maps for bushwalking and canyoning using QGIS. If you haven't watched the first video, then you should definitely do that, as this one picks up from where we left off. In that first video we saw how to get LiDAR-based DEM data from Elvis, the Australian elevation data site, to load that data into QGIS and merge it, to create contours and style them, and to create a slope map and style it. We'll be starting from where we left off, so if you haven't still got QGIS open with the data, I'd suggest running through the steps in the previous video quickly. In this video, we'll be looking at how to add streams and watercourses to the maps that we created last time. One of the trickier things about QGIS is that it doesn't come with tools to create streams out of the box, so we will need to install a couple more pieces of software. We'll be able to use these tools from within QGIS, as QGIS has plugins that help other tools to interface to QGIS. The first one we're going to install is SAGA GIS. Now on Windows, SAGA actually comes with QGIS, so you can probably get away without installing anything else. Go into QGIS and go to Plugins, Manage and Install Plugins. Select all and type SAGA in the search box. The one you want is called Processing SAGA Next Gen Provider. In case you do need to subsequently download it, have a look at which version of SAGA it supports. Currently it supports SAGA 9.1 plus. It'll probably work with later versions and earlier versions, but it's hard to know. I'm successfully running it with version 9.3.2. Click Install Plugin to install the plugin. Alright, now you need to configure where SAGA is installed. So close that. Go to Settings, Options, go down to the Processing tab near the bottom. Open up Providers and SAGA NG and double click next to where it says SAGA folder in this empty space here. You'll need to navigate to where QGIS is installed on Windows, and that's likely to be under C Program Files, QGIS, whatever version, in my case 3.34.5. Go into Apps and then select SAGA 9. Right, hit OK. And after a few seconds, you should now see in the processing toolbox on the right that you have a new set of tools under the SAGA Next Gen menu. If you had any issues, you may need to get the SAGA files directly from the SAGA project. You can open a browser and head to sourceforge.net. /projects/SAGA GIS. So the link's in the description below. Go to Files, not Download, which will get you the most recent version. And you can download the appropriate version. Unzip the files to a folder, e.g. c/misc/saga, and then go through the same steps to tell the plugin where to find the folder. If you're on Mac OS or Linux, you may need to do a bit of Googling to get the binaries. The other piece of software we're going to install is called Whitebox Tools. Go to www.whiteboxgeo.com/download-whiteboxtools. The link is in the description below. Scroll down. You can set the donation to 0. click download and then download the file directly. A donation is welcome if you continue to use the software. Download the zip file and extract to a folder, for example c:/misc/wbt. You can pause the video while you do this. Then go into QGIS, go to Plugins, Manage and Install Plugins, select all, type Whitebox, all one word. There are two Whitebox plugins, one called Whitebox Workflows for QGIS, and the other is called Whitebox Tools for QGIS. The one you want is the Whitebox Tools for QGIS plugin. So select it and then click Install Plugin. Similar to SAGA, you need to configure where Whitebox Tools is installed. So close this down, go to Settings, Options, and down the bottom to Processing. Open up Providers again, Whitebox Tools, and double click next where it says Whitebox Tools Executable. Click on the three dots, and then you'll need to navigate to where you extracted Whitebox Tools. Select the Whitebox Tools exe. Hit OK. And if all has gone well, you should now see Whitebox Tools in the processing toolbox. So now we're all set up, we can use the DEM data to create watercourses. We have contours and slope maps, but we don't have any actual streams or rivers. While streams may not be as important for navigation and route finding, they're essential for creating a nicer looking map. There are a few steps involved in this process. If you haven't been able to install all the necessary tools, then you might encounter issues during some of these steps. Before we start, I'm just going to remove the past 30C GPX layer that I loaded last session. So I can right click and remove layer. Okay, let's get going. The first tool we need to use is under Whitebox Tools. Now, instead of searching through hundreds of tools, I'm just going to type Breach into the search bar. The one we're interested in is called BreachDepressions under Whitebox Tools, and it's specifically in the Hydrological Analysis toolbox. Select the input DEM file, which in our case is the merged one and not the slope map that we created last session. You can leave the other settings as defaults for now and click Run. These stream creation tools might take a bit longer to process, but since we're not working with a huge amount of data, it should be manageable. After running the tool, a new layer will appear, named Output File by default. This name isn't very meaningful, so you can rename it. Hit F2 on Windows to rename it. I'm going to call it Breach, because we've just run the BreachDepressions tool on it. The reason we perform breaching depressions is to ensure that water can always drain from top to bottom in the DEM. Without this step, you may end up with sinks where water collects but can't escape, which disrupts the algorithms that generate streams. By breaching depressions or filling sinks first, we prepare the DEM so that the subsequent steps will work properly. Skipping this step can lead to crashes or poor quality output in later steps. There are some algorithms that can work around this, but we're just doing an introductory session, so we'll stick to the basic stream creation approach. One thing to note is that there is an alternative to breaching depressions called filling sinks or filling depressions. If you type fill in the search box, you will see a few of these algorithms. If you look online for tutorials around stream creation, you'll probably find recommendations to use the fill approach. But for the steep country in the Blue Mountains, I've generally found that BreachDepressions is the better approach, so that's what we're using today. Once you've completed that breach step, the next tool to use is called D8 Flow Accumulation. So type D8 Flow, all one word, into the search bar and select the tool named D8 Flow Accumulation. Double click to open it. By default, the tool will usually populate the input with the most recent layer that you've worked on, which is exactly what we want since we just created the breach layer. But otherwise, select the breach layer. You'll also want to check the box for log transform the output. This step is important because water accumulates exponentially as it flows downstream, meaning small streams combine to form larger streams and then rivers. Log transforming the output makes the data grow more linearly, which is easier to operate with and visualize. Humans are not very good at interpreting exponential growth. Once you've selected the breach layer and log transform the output, select Run. If everything is working correctly, you'll see an output that resembles the veins of leaves on a tree. This is essentially your raw map of the streams, showing the areas where water accumulates more as it flows downhill. The darker areas represent the ridge tops. The lighter areas represent where more water has accumulated, the channels and streams. So I'm going to hit F2 again and rename this to D8 Flow. Now to create the actual watercourses, we'll use one more tool called Channel Network. So type channel in the search bar and select Channel Network under the SAGA toolbox. You have several options that need to be configured. So elevation, this is the DEM, but we use the breach layer rather than the merged one. Initiation grid, select the D8 flow layer that we just created. Initiation types greater than. The initiation threshold, we're going to set this to 8.7. Now you're probably going to wonder why 8.7. The threshold value determines the number of streams generated. The lower the number, the more streams you'll get. If you use a higher number, you'll get a smaller number of streams and only the larger ones. You can play around with this figure, but I've done a fair bit of testing. 8.7 provides a good balance. It will generally generate a few more streams than found on the topographic maps, but not excessively. If you want the same as the topo maps, I've found around 9.6 to be about the right threshold. If you did not log transform your output in the previous step, the D8 flow accumulation, then you will need to come up with a completely different threshold number, probably one in the tens of thousands or possibly hundreds of thousands or more. Alright, once you've configured the settings, click Run. The tool may take some time to process as there are several steps that it runs through. Alright, that process is complete for me. Depending on your computer's speed, it might take longer to complete, so you may want to pause the video. On the left-hand side, you should now see 3 new layers. 2 labelled Channel Network, 1 labelled Channel Direction. One of these has a small line icon. indicating that it's a vector layer. 2 others have chessboard icons indicating that they're raster layers. I'm going to remove the 2 layers that we don't need, which are the 2 raster layers. However, if you find the raster channel network layer useful, you can keep it. So to remove them, we'll just right click and select remove layer. I'm also going to hide the D8 flow and breach layers that we created earlier. They're only needed for processing. Okay, so now you should be able to see your channels. In my case, they're appearing as sort of purple lines, which is not that visually appealing for streams. So like we did before, let's improve the styling. So double click on channel network, go to symbology. For color, I'm going to pick a shade of blue, and I'm going to change the width to 0.5 millimeters. Hit OK. So this makes the line stand out much more clearly. You'll now see the streams more distinctly, and you can observe how the tool has picked up even pretty small watercourses. That said, if you look at the contour lines, you'll see that some small gullies haven't been marked as watercourses because they're still too small, but it's a fairly impressive level of detail. Now, similar to contours and slopes, I've provided a pre-made style, although what we've just applied here is a pretty basic style, so it doesn't add too much. So double click on the channel network, go down the bottom to Style, Load Style. Navigate to the folder where you unzipped the course files and select Basic Watercourse. Load, OK. And you'll see there hasn't been a huge amount of change. So that's it for this second session. I hope you found it useful. Keep QGIS open, as when we pick things up again, we'll talk about how to save the data and the project. Thanks for watching, and see you next time.